So what we are going to do is transformations. Yeah. So transformations are of three types. Translation. Translation means moving your graph left or right. You remember that? You did that, right? Dilation means how narrow or broad the graph is. I'm taking the example of a parabola here, right? We'll take an example of a parabola and we will understand this in a bit more, uh, in a bit more depth. And reflection is what? Reflection means the side on the side of the graph. Where is this? Which side the graph is of the axis? Which side of the graph? So which side of x-axis or y-axis the graph is facing? So that is the reflection in a very, very layman terms. Now, let's take an example of translation. I take the example of a simple curve, which is y equals to x squared. So y equals to x squared. Now, we'll take the example of translation, which is y equals to x squared. Now, y equals to x squared is a graph that has its turning point at 0, 0. X is 0, y is 0, correct? Now, if I want to push this graph, so let's say this was my original x and y, which is 0, 0. Now, let's say I have pushed this graph to this new point, x dash comma y. You see, y has not changed. Y is still 0. What we've done is we've pushed x. Let's say we've pushed x by 2 units on the right hand side. So plus 2, right? So what is this x dash? X dash is what? X dash is actually your x, the original position, plus 2, correct? Now what we do is we rearrange this x, this equation, back into the x as subject. So I'll say x equals to what? X dash minus 2. But did y change? No, I did not change y at all. So y dash, the new position, is still equals to y because I did not move it at all. I just moved it on the x-axis. Now I have this equation, which is y equals to x squared. Now let me just plug in these new values of x and y into the equation and see how does that look. So now y is y dash. So I'll say y dash because y is y dash. And x is x dash minus 2. So I'll say x dash minus 2 whole square. So this is how my new translated equation will look like. So whenever you see any equation which says y equals to x minus 3 whole square, it actually tells you that you have pushed this graph 3 units on the x-axis on the right. Now, why this x dash and y dash has become x and y is that if I now make my x dash y dash as my new point of reference, I say, okay, this is my new x and y. So I can write this as x equals to, so y equals to x minus y, sorry, x minus 2 whole square. So this is my new reference position. So don't confuse whenever you see x minus 3 or x minus 2 within the whole square. For example, if I take this example of a parabola, that it is going towards the left. No, it is going towards the right. We've just proved it here. Right? Make sense? All right. Now, let us say I am now going to push my graph up. That's my parabola. And let's say this is x comma y. Now I've pushed it, let's say 2 units up. That's my new point. All right. See, I'm giving you the gist of all the transformations in one go so that we do the questions later. Now, let's say this new point is again x dash, y dash. What is x? Has x changed here? Has x changed here? No, right? Because I've just moved it along the y-axis. So x remains 0 here. I did not change x, but y has changed. Y becomes y dash equals to y plus 2. Correct? Now, what is, using this equation, what is y? Y is y dash minus 2. Now, my original equation was y equals to x squared. Let me just plug in or substitute these new x and y into my equation. So y has become y dash minus 2 and x has become x dash, so x dash square. Is this okay? So what is y dash? Y dash is x dash square plus 2. So now if this new x dash y dash is my point of reference, new point of reference, so I can say y equals to x square plus 2. So when you're moving your graph up or down, it works as normal. So plus means moving up, and if I have pushed it, let's say minus, so this would have become y equals to x square minus 2. Does that make sense? Now, let me just write a combined statement. So let's say my original graph was y equals to x square. Now it has become y equals to x minus 2 whole square plus 2. So basically, if I ask you what is the transformation that has happened here, so you will say that we have moved the graph 2 units on the right of x because it's an x minus 2 and 2 units up on y. How would that look? So first of all, if this was your original graph, let's say y equals to x square, you first of all moved it 2 units here. So the graph came here and then you moved it 2 units here. So now this is the point. So this is how the graph will look like. And its turning point will be 2, 2. The general equation of parabola is y equals to x minus h whole square plus k, where h comma k is the turning point. Now if I match this equation with my given equation, my h is 2 and k is 2. So hence k, h comma k, 2 comma 2 is the turning point. I should be able to tell this without even without even drawing the parabola. Because what's happening here is transformation of h units on the right hand side and k units up. Make sense from a transformation perspective? Now, let's do the dilation, the second form of transformation. My original graph is y equals to x square. Now let's say, what is the coefficient of x square? Coefficient of x square is 1. The coefficient of x square is called the dilation factor. Dilation factor. So the dilation factor of this parabola is 1, right? Dilation factor of this parabola is 1. Now if I write something like this, y equals to 2x square. This is dilation of a dilation factor of 2 because now your coefficient of x square is 2 from y-axis. Now, what does that mean from y-axis? So what will happen if you draw the graph of y equals to 2x squared? You know what you'll get? You'll get a narrower graph. You'll get something like this. So if this was your original point, it'll come here. It'll be pushed towards y-axis. It'll be pushed towards y-axis. So that is why it is a dilation factor of 2 from y-axis, right? And let's say if you have y equals to probably y equals to half x squared, you know what will happen? Now you are dilating. Dilation factor is half from y-axis, and you know how the graph will look like? This is how the graph will look like. What you've done is the same point, you've now pushed it away from y. So whenever your dilation factor is greater than 1, if I say my dilation factor is a, so for example, my parabola is y equals to ax squared. A is the dilation factor. So whenever my a is greater than 1, for example here, the graph is pushed towards the y-axis. And whenever my a is between 0 and 1, that means it's a fraction. It's a smaller number. Here, the graph is pushed away from the y-axis in context to the parabola. The mouth of the graph becomes broader, and here the mouth of the graph becomes squishier, right? Now, let's talk about reflection. Reflection, so let's say if you've got a graph y equals to x squared, and this is x-axis. If I have to reflect it in the x-axis, this is how it will look. What has changed from this graph to this graph? The values of y. Your y in this graph was a positive y. The y in this graph is a negative y. Correct? But x remains positive. So your your x dash remains x, but your y dash becomes minus y. Right? So if I plug it back here, so it becomes your y dash is minus y equals to x squared, or y equals to minus x squared. So if you see a negative sign in front of the x, especially in context with parabola, you have reflected the graph in the x-axis. You see here, you have reflected in the x-axis. You see, you have flipped it here, right? Where do you reflect your image? You reflect your image in the mirror. The mirror is right opposite to you. So this x-axis works as mirror for this parabola. Does that make sense? So this is shear reflection. Now, if in context of y reflection in the y-axis, if I flip it like this, the parabola will still look like the same, right? So if I make x dash as minus x and y equals to y dash, and if I plug it in, I'll say y dash equals to negative x dash square. So y dash equals to x dash square. Doesn't make any difference. So the parabola still remains the same. So reflection of parabola in the y-axis doesn't make any big difference. It's reflection in the y-axis that make a difference. Now, lastly, if I combine one and I write y equals to minus 2 x minus 2 whole square minus 2. So what has happened here? We have reflected the graph in the x-axis here, reflection. We have dilated by a factor of 2 from y-axis. This tells me I have moved the graph 2 units on the right of x, and this tells me I have moved the graph 2 units down on y. So that is the combined reflections that are transformations that are happening on one single parabola. All good.